Dr. Saffell received her BS, MA, and PhD degrees in Geography and Climatology from Arizona State University. Her main research interests are extreme weather events, including flood and drought, as well as health impacts of the urban heat island. Dr. Saffell is a senior global futures scientist with the Julie Ann Wrigley Global Futures Laboratory.
Great. Thank you very much for that nice entry. I'd like to go ahead and share my screen. And so I'll go ahead and do that, and we'll make sure everything's working okay. So here we are, and we'll go ahead and see if we can get all the technology working. Welcome, everyone. And I appreciated the folks that identified North Pole as their one of their areas that they wanted to go to, because it's going to feel like that to me as we have this cold front passage. It's really cold. I didn't see Star Wars, so I'll keep my Star Wars comments to a minimum, but I'm really grateful to have this opportunity to talk with everyone and give you kind of an overview of what's going on with the climate of Arizona, how it operates, kind of some of the arenas that we want to pay attention to when we're talking about health concerns. And so that's what we're going to be talking about today. So let me go ahead and go to the next slide. And this is a slide that I use in some of my introduction physical geography classes. All three of my degrees are in physical geography, which is an interesting way of looking at the world. In fact, as the sixth state climatologist, all of the state climatologists for Arizona have always been physical geographers. What that brings is a way of looking at kind of things across space. We look for patterns. We want to understand why there's a desert where it's located and why there's not a desert somewhere else. And so when we look at our maps, those really help us find those spatial patterns. And when you're looking here in Arizona, we're looking, of course, at the map of the globe and where the deserts are found. We have hot deserts and we have cold deserts across the globe. Arizona, and particularly central and southern Arizona, are in what would be considered a hot desert. So we have hotter temperatures and drier conditions. And in fact, Arizona as a whole is in arid and semi-arid climate zones. So that means that we don't get a lot of precipitation, but our temperatures are much, much warmer than what you might find in other states in the United States. And so absolutely looking at that kind of setting helps us understand what kinds of issues that we might have to deal with health-wise in Arizona. And a little bit about what's going on with our temperatures and kind of how we think as climatologists, what our data will say. We've been measuring temperatures across the state since about 1895. So we have a fairly long record of over 125 years that will help us understand changes in our climate system. And so when we're looking at temperatures, what you're looking at here is the average annual temperature for the state. So we're looking at all of the data that's collected across the state and then adding it all together to get one number that represents what happens in the state of Arizona and what happens annually. So we're not seeing the extreme highs and the extreme lows. We're looking kind of at the average conditions. And you can see since 1895, we have hotter years and we have colder years. And that's absolutely normal for what happens in arid and semi-arid climates. But as you can see, since about the 90s, temperatures have been increasing. And we're seeing that there's an increase in temperature across the state. So not just one specific location, but on average across the state of about 2 degrees Fahrenheit change in the last 100 years. So absolutely, that's what we're seeing. We see a little bit more of a detail when we look at urban locations in the state. With precipitation, generally in arid and semi-arid climates, we don't see patterns necessarily, except for patterns that show where we have extreme amounts of precipitation and small amounts of precipitation. So we can have really wet years and we can have really dry years. And that's a normal situation that we see here in Arizona, especially as our arid and semi-arid climates. I'm going to go ahead and actually block the video because it looks like I'm having a little bit of a technical issue. So I'm just going to take myself off the screen and still talk to you. So we'll do that. And hopefully that's working okay. And we'll continue our discussion. Okay, so what you're seeing is the same kind of presentation slide of the data that shows, the average annual precipitation for Arizona. So that one dot represents what happened for that year, and it's January through December. And then you look at the last years since about the mid-90s, and we're definitely seeing that trend of lack of precipitation, that deficit that we've been seeing since about the mid-90s. Okay, folks, welcome to how climatologists look at numbers. So we keep track of a lot of different things. This is actually from the National Weather Service, keeping track of numbers for us, but it kind of gives you a sense as to when we first get 85 degrees Fahrenheit in Phoenix. So this is zooming into Phoenix. How early can we get 85 degrees Fahrenheit in the year, and how late can we have 85 degrees Fahrenheit? So kind of gives you a range, gives you a sense as to, what the average time when we're going to get 85 degrees, when it starts to warm up and when it starts to cool down. And so we keep track of those numbers. It's a bunch of statistics, and you can kind of see that the average first date when we get 100 degrees is May. So the first part of May, although we can certainly have 100 degrees happen earlier than that. And that's one of the situations to pay attention to, is so, our bodies acclimatize, we get used to these temperatures. And if we're starting to see changes in those temperatures a little bit early, our bodies may not be used to that, and we may be susceptible to heat-related illnesses. So looking at these kinds of ideas, June is the hottest and driest month in Arizona. June is when we experienced the hottest temperature ever measured in Phoenix, which was 122 degrees Fahrenheit, and that occurred June 26, 1990. So when we're looking at Phoenix, we have a lot of hot temperatures in Phoenix. Yuma also has a lot of hot temperatures, and that's related to our elevation. So the elevation of Phoenix, we're actually lower than Tucson. We're much lower than what you see with Prescott and Flagstaff. And so that really plays a role in Phoenix being hotter. And then, of course, Yuma being hotter because it also has a lower elevation. Phoenix averages about 21 days each year with 110 degrees Fahrenheit or higher. And so we're seeing an increase in the numbers of 110 degrees, which are considered to be very hot. Most bodies have a hard time handling those higher temperatures. You may have been here in 2020. 2020 was a record-breaking year in a lot of senses, but we had the most numbers of 110 degrees Fahrenheit temperatures in 2020. We had 53 days that year. So we're going to start talking about heat and how heat feels to the body, some of the terms that we pay attention to, what people are watching with the statistics, and give you a sense as to what's going on with heat in Arizona. First, defining that term for you, heat wave. So a heat wave has a very specific term when we look at it climatologically and when we look at it meteorologically. And that means that we're going to have 2 days of excessive heat or more. And what that means is that most bodies can handle 1 day of excessive heat, but most bodies can't handle 2 or more days of excessive heat. And so that's when we mark what a heat wave is. heat accumulates in the body. And this is a particular issue when we're transitioning. So we're moving from winter where it's colder and our bodies are used to those colder temperatures. And then we transition to the warmer temperatures in the summer, which our bodies become used to. It's those transition that can be problematic, especially in spring. As we're here in fall, we start to cool off, our bodies get used to the cooler temperatures. And then if we have, a more extreme temperature that comes in, that can be a problem for people's bodies. We look at statistically kind of the threshold where this high temperature doesn't happen that often. And so very much looking at the climatology of heat in our cities allows us to say that this is a more extreme type of temperature that we would experience at this particular date. So heat waves have a definition. And then Maricopa County. Maricopa County plays a really large role in understanding the numbers of heat-related deaths in Arizona. So based on our population in Maricopa County is the hottest, most populated county in Arizona. There's around 4.5 million people that live in the county. That means there's about, over 60% of the population in the state resides in Maricopa County. And Maricopa County, if we want to extrapolate and look at the country, Maricopa County is the fourth most populated county in the United States. So that's interesting to kind of think of when you look at Los Angeles, they're going to be number one. You look at in Illinois, you've got other cities, but here in Maricopa County, we're definitely number 4 on that list. And when you look at our temperatures, you kind of, Houston ends up being number 3, the county that has Houston in it. They end up being number 3 population. But with our temperatures in Phoenix and Maricopa County, we tend to be a little bit higher than the temperatures in Houston. So even across the country, Maricopa County has a really large number of people that are dealing with large amounts of heat. And so Maricopa County plays a role in monitoring those heat-related, heat-associated types of fatalities and issues that happen. Last year, Maricopa County reported over 300 heat-associated fatalities. The county will report fatalities as either heat-caused or heat-related. So you'll see that. That's what we're seeing down at the bottom, the bar graph that's down at the bottom starting in 2006. Heat-caused means that heat specifically caused the death. Heat-related means that heat contributed, but is not the direct cause. And so you can see heat caused in the red, heat related in the orange. And as we progress, since we've been monitoring these heat associated deaths, the numbers of deaths, and this is just for Maricopa County, have been increasing. We're looking more at the reports from the 2021 Maricopa County heat death report. And so when we're looking at this, it's important to remember kind of the seasonality, how temperatures change in the particularly across the year. And we recognize that the hottest temperatures, the hottest and driest temperatures happen in June. We get very little precipitation in June, very few storms, and very hot temperatures as a result. So when we don't have a lot of moisture in the atmosphere, our temperatures can get really, really hot. So June is usually fairly dry, and that allows higher temperatures. We've set, so meteorologically, in the meteorology division, we've set the monsoon season as June 15th to September 30th. But that doesn't mean that we won't get thunderstorms outside of that arena. It's more along the lines of public awareness to make sure folks are paying attention to what's coming up. It's very similar to how the hurricane season is set. So public awareness based on actual thunderstorms. But as thunderstorms begin in the monsoon season, they usually start down in Tucson and then they progress up. We'll get some maybe in Wickenburg, along the Mogollon Rim, and then they'll come down into the Phoenix area a little bit after that. You know, the higher moisture that we start getting in when we get those thunderstorms, we measure that with dew point temperature specifically. So you may remember how we mark the start of our monsoon season with high dew point temperatures. We still keep track of those numbers, but higher moisture, it moderates the temperature. So we won't get as hot of the temperatures. So we won't get up to 120 degrees typically in July. But those higher moisture levels in the atmosphere won't allow your body to cool off as effectively. And so higher temperatures and higher moisture levels, higher relative humidity, higher dew point temperature, it makes July the month where you have the highest proportion of heat-associated fatalities. And so that's what we're seeing on these charts. And you can see how July just crops up with the heat-associated fatalities, because even though it's not as hot as June, it's still pretty hot, and there's a lot of moisture that doesn't allow your body to cool off effectively. We can't sweat effectively and cool our body effectively in July because of the high amounts of moisture. So now we're kind of considering, and this again is from the 2021 annual report for Maricopa County. Maricopa County publishes weekly data reports, and they identify the heat season as May to October for their reports. And so that's the data that we're looking at here. For Maricopa County, the majority of heat-associated deaths occur outside. So the number of outdoor fatalities, they're statistically more for males than females, and that's for the outdoor types of statistics. Indoor fatalities tend to statistically be more females than males. When we're looking at those outdoor fatalities, they can include people that are in a work-related job. Those can be people that are performing leisure activities like hiking, or it can be people that lack permanent housing structures or have no access to cooling types of conditions like air conditioning. And then, just as we've seen before, the greatest number of outdoor deaths are going to occur in July. So again, looking at reports from last year's annual report for heat-associated deaths, what we're seeing since 2006 all the way up to 2019, so not at the very end there, the majority of heat-associated deaths were people that had permanent housing. So what you're looking at here are kind of the bifurcation between folks that do have housing structures and folks that don't have housing structures. And so the red at the bottom is showing you the people that don't have access to a permanent housing structure. And as you see through 2019, the larger number of fatalities associated with heat occurred with people that did have permanent housing structures. And then that kind of changed a bit with what we saw in 2020. A little bit about 2020 and what happened in 2020. 2020 was an exceptionally hot and very dry summer. That's when we first started dealing with COVID. And the homeless population in 2020 accounted for 60% of the heat-associated fatalities. So on average, the homeless population accounts for roughly a quarter to a third of heat-associated fatalities in Maricopa County. And when we're looking at the heat watch and the heat warning, that's issued by the National Weather Service. And again, it's evaluated based on statistical levels of temperatures that are forecasted for the next few days. And so when we see a situation where the forecast is going to show temperatures that exceed normal amounts, so statistically they are the highest level of happening, that's when heat watches and heat warnings are generally issued. There's a lot of work being done at the federal level with the National Weather Service and with folks in Arizona and other states to create a heat watch warning system that's easily understood, that's able to be transmitted to a large amount of the population, that would help people understand what that actually means. It can be challenging when we're putting out these watches and warnings and expecting the general population to understand what kind of response we expect, but typically when we're dealing with heat watches and heat warnings, we want folks to remain hydrated. We want them to find cooling locations so that they can cool off. Typically, if the body cools off at night, that allows that next day to be able to handle, as long as that person is in fairly good shape, it allows them to be able to handle that next day that might have hotter temperatures. And so it's based on those kinds of situations. And that's important to recognize how your body handles heat at all times. Because when we're looking at the heat-associated deaths, and this is we're kind of looking at 2016 to 2020, only about a third of those heat-associated deaths occurred during a heat warning. There were other fatalities that occurred when there were no heat warnings. And so that's important to understand how the body operates. And so looking now at this year's heat season, so again, we're looking at May through October, and I grabbed these, so just till the end, so up till the 18th of October, there have been a confirmed 359 heat-associated deaths, and that again goes to October 18th. So there could be additional fatalities that have happened since that time. The greatest number occurred in the statistically high month, which is July. And that, again, is where we have the hottest temperatures, but we also have the highest humidities. And so the body doesn't cool off as effectively. And you may remember, if you were here this summer, it was a very active monsoon season. But even still, we had a lot of precipitation. July for the state, if we're looking at a state temperature, it was the 12th warmest July on record. So it was still very warm. And for Maricopa County, it was in the top 20% of the warmest Julys for Maricopa County. So even though we did have precipitation, we're still dealing with heat, and the body accumulates that heat, as we mentioned. And so another consideration when you're looking at these heat reports from Maricopa County, the heat season this year to date, so when I pulled this information, it ended at October 15th for this chart. For this year, there were 72 indoor deaths up to October 15th. And so it's interesting to look at those folks that did have indoor structures and did have air conditioning. And the majority of heat-associated deaths were with people that had an air conditioning unit present in their home. But then you dig into those numbers and you can see a lot of times the air conditioning unit wasn't functioning, or they didn't have electricity, or it just wasn't turned on. And so that's an important consideration when we're looking at who is susceptible to these heat-related and heat-associated illnesses and fatalities. And so when we're looking at these numbers, 20% of those deaths had no air conditioning at all in the home. March and early April, so if you're looking down at the bottom where we've got those green lines coming up, those are heat-caused deaths. There was one that happened in mid-March. There was one that happened in early April. March and April from this year, we're very hot, very dry, and you transition. Those are transition years. And so if people haven't accumulated or acclimatized, and they're used to being in cooler temperatures, and here we have maybe a 100-degree temperature on the weekend, and folks might go hiking, they may be susceptible. And so those transition seasons, that's kind of what we see happening during those times. All right, excellent. I see that there are questions in chat, so I'll try and make sure that I have time and we can answer those questions at the end. So I see that we're about halfway through our time. What I'm going to talk about next are kind of the materials in the atmosphere that can be brought in through respiration and may cause respiratory issues. So we're going to look at ozone and particulate matter in general, those atmospheric constituents. And we know that ozone can be good and bad depending upon where it's found. So we know that ozone is good in the stratosphere, but we're not living in the stratosphere. We're living in the troposphere. We're down here at the surface. And so when ozone is formed down here at the surface, it happens typically in the summer. It happens when we don't have storms, so we have clear skies, and we have a lot of sunlight coming in. And what that can do is it can create ozone down here at the surface. And in fact, you'll see warnings put out saying it's going to be a high ozone day, stay inside. One of the other recommendations is to not go and put gas in your car, because those materials that are in our gases assist in the creation of ozone. And so that bad ozone at the surface actually can cause problems. And it's typically a summer type of situation. If you were to see, according to the American Lung Association, when you're breathing in that ozone, it can act as a sunburn on your lungs. And so it's a respiratory irritant for sure. Not is usually an issue that we have in the transition seasons or in winter. It's typically a summer-based situation because of the sunlight. The sun is at a higher angle. We're getting more incoming UV, and we're able to create more ozone at the surface on those specific days. Other things that are measured and monitored, particulate matter. The particulate matter is suspended material in the atmosphere. So solids in the atmosphere that are held in suspension from, air that rises in the atmosphere. And we can breathe in those materials. We're measuring those materials, and we measure what's that particulate matter, and we abbreviate that as PM. So when you see a PM warning, we're talking about these suspended materials. And the sizes of those particulates, it's not something that we can generally see with our eyes, because the size of these particulates are very, very small. We measure the size of the particulates in microns. And a micron is a millionth of a meter. It's 10 to the -6. So it's really, really small. If you were to look at your hair, and you were to pluck a hair out of your head, the width of your hair is typically around 100 microns. It's not the length of your hair, but it's the width of your hair. And so that's the size. Smaller than your hair is the size that we're measuring and monitoring. Dust. So when we do have dust storms and you have that accumulation of dust, typically you can see that because there's a lot of accumulation of dust, and it decreases visibility. So we can typically see when there's a lot of dust in the atmosphere, but a lot of times we can't. We look at that and measure that, and that's particulate matter 10. So PM10 is when we're measuring that, we're talking about dust. And then PM 2.5, which is even smaller than dust, what we're talking about there would be smoke. And there are certain times of the year when we have more dust in the atmosphere and when we have more smoke in the atmosphere. So we'll take a look at when that happens. So a little bit about the monsoon season, because this is going to introduce us to when we get our dust storms quite a bit. And so when we're looking at the monsoon season, which was exceptional this year, we really had a great monsoon season, a lot of precipitation, which is great because that does take dust out of the atmosphere. we will have this kind of circulation that brings in moisture from the south. And so you can see our arrow kind of over New Mexico and Arizona right there, bringing that moisture in from the south. And so that setup happens when we have high pressure kind of over the Great Plains, over Texas, over the Four Corners region, because of that movement that happens around high pressure. So it brings that moisture in from the south. And so we're really grateful to see all of that. In fact, New Mexico was especially grateful when they started getting their monsoonal precipitation. It started putting out a lot of their wildfires that they have been experiencing. But when we have death storms with our monsoonal thunderstorms, it decreases visibility, so we have problems on the road, but then it also can put dust and fungus and all sorts of materials into the atmosphere that can be breathed in. And so the way our death storms operate in the monsoon season is typically they look like this, like that wall of dust. We had a lot this year. And it happens because with thunderstorms, you have the warm air that rises and the cold air that comes down. And that cold air comes down and hits the ground and moves out ahead of the thunderstorm. And so if we have loose materials at the surface, which we're in a desert, that's what we have, it can pick up those materials, those particulates, and advance them and move them forward ahead of the storm. And that's a typical summer dust storm that we experience. One of the situations when we're lofting the dust and the materials at the surface, we're lofting them into the air, we can take the fungus that's resident in our dust that can become airborne and can be breathed in. And so when we have the fungus spores that are responsible for valley fever, when they're breathed in and inhaled, that becomes problematic. You have the potential to generate valley fever. Valley fever, it can be a long-lived process for the person that ingests and gets that situation. It can lead to a lot of respiratory issues, cough and fever that can be long-lived. But this is largely something that we pay attention to in the summer. And it's largely something where we see a lot of that dust being lofted before we have our thunderstorms. So when we get our thunderstorms, that water on the ground actually can keep those spores at the surface, and so they won't be lofted as much. But in 2020, we only had 2 days of precipitation in Maricopa County in the Phoenix area, and so it was very, very dry. Fortunately, there weren't many dust storms, but you still have that potential when we're dealing with those kinds of dry conditions. And then this is what we deal with in the winter. So we're kind of dealing with it now. When our temperatures start to get colder in the winter, what that'll do is it will trap particulates closer to the surface. So when we look out across the valley, if you're here in Phoenix and Maricopa County and you're driving on the 202 or the 10, and you look forward early in the morning, even late at night, you can see kind of that accumulation of material closer to the ground. We call those materials, or the reason why we have this situation happen, we call that an inversion. And that's because that cold air is held closer to the ground and it's trapping the particulates down here where we live. Normally, when we're warming up the ground, we have warm air that rises, and that will kind of mix the atmosphere and move some of those particulates away from us here at the surface. But when it's cold, cold air will sink. Cold air comes down, it's heavier, it's more dense. And so that colder air stays down here closer to the ground, and that's particularly in the mornings through the evenings. So it hasn't warmed up during the day. When it warms up during the day, we kind of mix and remove that inversion. But early in the morning, late at night, we have that colder air down at the surface, creating that inversion, which traps It can trap if you're having a fire at your house, having something nice like that. It can trap all of that smoke. And then, of course, that can contribute to what we call here in Maricopa County the brown cloud, which happens in the winter. It happens because of an inversion, and it traps the PM 2.5. So the smoke traps down here at the surface. Again, this is largely a winter issue. So we have dust storms in the summer. We have kind of inversions that trap particulate matter at the surface in the winter. And then that can absolutely cause respiratory harm. And you'll see ads put out saying, a no burn day. It's referring to the fact that we expect the inversion to remain resident and trap that particulate. You'll see that happen with the no burn day on holidays. You'll see it happen with January 1, launching fireworks. You can smell that. You can absolutely smell that in the air when we're dealing with these inversions. So we do have a state agency, the Arizona Department of Environmental Quality, that will put out forecasts for ozone production, for particulate matter 10, so PM10 and PM 2.5. And so you'll kind of see good days, bad days, and they'll set it up through the day. So hourly, you can have these reports. If there's an expectation of a thunderstorm, creating a dust storm or blowing a lot of dust, you'll see the PM10 registers advance. If we expect an inversion in the morning or late evening, you'll see the PM 2.5 advance. The ozone, you'll see that advance typically on clear days in the summer. So absolutely something to pay attention to and use those resources that we have. And then the last little bit that we're going to talk about is about water in Arizona. When we're looking at our water supply in Arizona, we're fortunate in that we have a very diverse water portfolio. The majority of water in Arizona comes from groundwater, and that is managed in the active management areas. So about 80% of the population is having their groundwater managed, which means we won't take out too much and we'll put in enough water to recharge what is taken out. There's a lot of news about the Colorado River, as there should be. The Colorado River does not get its water supply from Arizona. We do use about 33% of our water supply comes from the Colorado River, but the water in the Colorado River comes from the upper basin. So we're dealing with Wyoming and Colorado and Washington. And the way that we get water in the Colorado River is with winter snow. And so we're hopeful that we'll start to see a lot of winter snow. Right now, we're dealing with projected La Nina, which means in Arizona, we typically don't get as much precipitation statistically during a La Nina, but that can mean that in Wyoming and Colorado, we may get some more winter snow, but that's the main water supply when we're dealing with our water supply, where it comes from is from winter snow. And that even is in Arizona, we want our winter snow because that will melt slowly and recharge our aquifers and our rivers. So we pay attention a lot to that seasonal type of precipitation. The outlook, so here's kind of what we're seeing. We'll see seasonal outlooks, and these are put out by the national agency, the Climate Prediction Center, kind of giving us a, statistically what the outlook may be for October, November, December. So this was put out, a year ago, or excuse me, not a year ago, a month ago. And we're seeing that, the temperature looks like it will continue to be a little bit warmer, above average temperatures. The consideration for that, when we're having above average temperatures in the winter, what that means is the potential for snow to remain resident decreases. So when we have warmer temperatures in the winter, that means we may have less snow. And so that can have consequences for what happens with our water supply. So something to consider there. And then the precipitation outlook, again, put out a month ago, looking for October, November, December, seasonal precipitation outlook. It's been updated since, but we're still looking at below normal amounts of precipitation that are expected here in Arizona for that winter. And how that plays a role is it plays a role in our drought. So we have what we evaluate here in Arizona. We evaluate short-term drought and we evaluate long-term drought. And we work with the U.S. Drought Monitor to look at it weekly to evaluate kind of what's going on with our short-term drought. And again, we've been in this longer term drought since about the mid 1990s. If you were to look at our precipitation, our annual precipitation in the last 29 years, 9 of those have been wet years, but 20 of those have been dry years, so below average. And so we're statistically and categorically dealing with a deficit of precipitation. It's been going on for a longer period of time. The way that we evaluate short-term drought with the drought monitor is with these colors. And so we have, the bright yellow, which is abnormally dry, and then we progress into like the more entrenched types of short-term drought. So we have moderate, we have severe, we have extreme, and we have exceptional. So you see that really the angry colors is what I call the reds, and that darker red, that maroon. Those are showing that we're in a more exceptional extreme drought, which means it's a more of a longer term than short-term drought. And in fact, if you look at where we were at the end of 2020, so recalling that 2020 was very hot, very dry, and as we progressed and moved into June of 2021, our short-term drought maps looked like this, very similar to this. So a lot of exceptional and extreme drought that was entrenched when we're dealing with those kinds of things. And so again, the reason why we want to consider not just precipitation, but we also consider temperatures is because a warmer atmosphere not only melts the snow, as we talked about, has that potential, but it also makes a thirstier atmosphere. And so we can lose that soil moisture when we have a warmer atmosphere. And so we're actually seeing much of the state in 2020, at the end of 2020, entrenched in that exceptional and extreme drought. So this is a little bit more current. If you want to follow tweets from my office, you'll see that I just tweeted this morning on the weekly drought monitor report for Arizona. And what we've moved into is kind of the central portion of Arizona. So you're seeing Maricopa County and Gila and Yavapai and Pinal County. That kind of hole in the middle has now turned to yellow. Abnormally dry conditions, the D0 on our scale, means that we're not technically in drought. It's just an abnormally dry condition. We've also seen improvement in the last couple of weeks. So where you're looking at Maricopa County in the middle, you go up above that, that's Yavapai County, and up above that where Flagstaff is, that's Coconino County. So you can kind of see that kind of orangey, darker yellow color, I guess we call it goldenrod. And then that's our severe drought. We've actually mitigated some of that. And so if you were looking at today's drought monitor, then we're going to have less of that severe drought, that kind of orangey goldenrod. We'll have more of that abnormally dry, which is technically not drought. It's just dry conditions. And then we do look at our long-term, as I mentioned, if we were to look at from the mid-90s, how many of those years have received surplus amounts of precipitation, how many haven't. We look at long-term drought in those kinds of ways, but also what's been going on with our temperature. And you can see that Arizona is still residing in our long-term drought. We evaluate our long-term drought every month, and we report on it every 3 months. we report it to the governor's office every 6 months. And so we're about to do that next week, reporting our level of long-term drought. And you can see the same kinds of colors. There's not as much exceptional, which is that angry red, that maroon, but we still have extreme drought in a lot of places, especially in the West and in the North. So looking at that long-term drought. Okay, so that is the information. So I'm going to go ahead and turn myself back on if I can, and you can see me, and hopefully that'll work. Yep, there we are. And I'm going to look at your chat questions first, and we'll see if there are any other questions. So I'm going to Jackie, and it says, so far in 2020, 209 heat caused, and yeah, thank you. Yeah, definitely. We're just continuing to see that increase. Thank you, Jackie. Jeremy, are there any composite statistics correlating homeless numbers with the rise of heat? So yes, you would want to go to Maricopa County and look at their heat reports, and they have very specific information. There's a lot more information available with their heat reports than what I provided. There are folks that are, they're quantifying those that may have drug use issues. So there's a lot of detail that you can find with the statistics. I'm very grateful for what Maricopa County has done, because this not only affects and helps Maricopa County, it helps other hot counties across the country. So I appreciate that. The large population moving to, and this is from Val. Val says, with a large population moving to Phoenix metro areas, I'm curious as to how many of those heat-related deaths are from the people that don't acclimatize. And we absolutely do see that. I think there are, because where they're getting their data, they're getting it from hospital reports, and they're getting it from the death certificates. So you can have those data. Those data are available. People that do come here, we see that a lot. They're not, they're excited with mountains, and they're here in Maricopa County and may not understand exactly what that means to their bodies. And so you probably can get those data, because I do know, I pay attention to those data. Stephen says, what type of mass? Oh, great, the valley fever exposure. I have not seen research on the mask for the valley fever. I grew up here in Arizona, and valley fever was just something that was expected. So, that's not the way to handle these kinds of situations. I'm not sure, but again, I'm not the expert with the spores and the respiratory irritants and those kinds of things that can happen with the valley fever. I suspect somebody has done research and does know that. Unfortunately, I apologize, I do not have that information. Heat stress is real. Yes, it is. Some are misted. So you bring up a good question about the misters. The misters may not be effective when we're dealing with high temperatures and high humidities. So if you've ever walked by one of those restaurants or those locations that have the misters, and so they're misting the air temperature, if you can see the cloud that they're making from all of that water, you're not going to effectively cool. So it's condensing in the atmosphere. The mister is supposed to evaporate the air temperature, and evaporation is a cooling process. That's what our bodies do when we sweat and the water comes off of our skin, it evaporates, which is a cooling process. When you see a cloud from the mister, it's condensing, which means that it's warming. And so it's not an effective cooling process. So that's something to pay attention to. Just as an aside, so this is coming from Stephen, I had an employer where the inversion layer, delta T, which is the change in temperature, was monitored. Interesting. Salt Lake City does a lot of monitoring for inversions because their inversions become entrenched and really stay a long period of time and trap a lot of particulates. So what you want to do is you want to get warm air and warm up the ground. The ground gets warmer. The ground, something to understand about our air temperatures. It's not the sunlight that warms up our air temperatures. The sunlight has to come down, hit the ground starts to get warm, and then the ground starts to warm up the air above it. And so it's a very slow process. So that's why when we're looking at when the hottest temperature of the day occurs, it's like 2 or 3 or 4, depending upon latitude and season. We're getting the most sunlight in at noon. The sun is the highest in the sky at noon, but we have to wait for that sunlight to come down, warm up the ground. The ground warms up the air temperature. And so that leads to some of the issues with having those inversions entrenched and not mixing and getting rid of. So the joke was, okay, it's good to wake up. Thank you, Stephen. That's awesome. Good presentation. Thank you very much, Greg. I appreciate that. Is this adjusted for topography ecosystem? How about the normal temps? So Stephen, can you give me more information about, shoot me another message and I'll watch for that for specific. I'm not quite sure how what you mean with being adjusted. So thank you. Jackie, Val, not as many heat deaths from new residents. Oh, good. Thank you for that information. Does change in rainfall specific to Southern Arizona sit in EPA 3 ecoregion? I'm not sure. I don't look at EPA regions. That's interesting. I will now that this is being brought to my attention, but typically with what's going on with what we're looking at when we're dealing with the EPA kinds of conditions, typically we're dealing with dust and ozone, that particulate kind of exceedances that the EPA watches for us. So that's just thinking how, those are interesting things. Yeah, interesting. The rats, valley fever, by the way, Val, used to be just for new arrivals, right? You know, from what I understand, and I may be off since the last I was checked for valley fever, we had to have an x-ray of our lung and they were looking for a black spot on our lungs, which is a mark that you've had valley fever. I don't know if that's current. I haven't been tested for valley fever in a while, probably about 15, 20 years. Thank you. I'm happy to have that information. Your data can be used. Yes, layering is great. You're exactly right, Stephen. Great. Okay, so hopefully I answered all of the questions. And please feel free to contact me. You can reach me at my email. You can look for more resources on the web. If you're seeing, you know, something missing, we need more information, let me know. I manage my website, so I can put more data onto the website as needed. And there's a lot of data on there. So I'm going to stop sharing and make sure that we've got everything covered. And I appreciate your time. But again, this doesn't have to be the end. You can always contact me and we can continue the conversation.
That was super great and very insightful. Thank you so much for presenting on that topic. And there was some people asking if the slides would be available. So I would just recommend probably emailing you directly, I'm guessing, if you're okay with sharing your slides.
Absolutely. I'm happy to do so.
Okay.
Thank you for your time.
Thank you for joining us.
Bye-bye.